Hello, it's Cliff here. In this video I'm going to introduce the Hallmark Lathe ToolSetter Fixed LTS-F, and it's actually a very simple little setting device that saves a lot of time when you're mounting and aligning your tools, and then when you're setting your tool offsets. It actually has some advantage over the more complicated lathe tool setters from Hallmark, and some disadvantages, and I'll go through those in this video. A few years ago when I got rapid turn, I found that having a D section, a piece of ground shaft split in half, was a real advantage for setting the tools, for mounting the tools and aligning them, and then for setting the tool offsets. And then when I got Slant Pro a couple of years later, I realized it would be really good to have some sort of index plate that could help with the rotary positions of the spindle, because you use these D-shaped setters in 3 different orientations: level, vertical to the front, and vertical to the back. So I developed this prototype, and I think there's a video on it there somewhere back in the archives of videos, of this original prototype of the Lathe ToolSetter F. And people have been requesting them with a 3/4 inch shank to suit the sort of standard Toolmax system. I've made a few samples of the Lathe ToolSetter F with a 3/4 inch shank and just ground them out of solid through hardened dowels, which are centerless ground. But that's not the way to manufacture them in a production quantity, obviously, but it was good enough to make a few samples. They have a little radius on the corner. I'm not sure if that's a good feature or not. I've ground them with a point on one end, and there's some real handy qualities to a little setter like this. You can use it to align. I'll show it on the machine rather than try and display it like this, but I'll take you through some of the pros and cons of the Lathe ToolSetter F in this video. Alright, cheers. Of course, one of the big advantages of the LTS Fixed LTS-F is that it's low cost. It's just a piece of through hardened cylindrically ground steel, accurately ground in half, and perhaps a point on the other end is very useful too. You could make your own, which would make it even cheaper. You could cut off a piece of high tensile steel or silver steel and split it in half with, for example, tungsten carbide end mill. But it really wants to be glass hard, so that if you're holding it in a chuck, you're not marring and bruising and scratching that precision diameter. I'll go through a couple of ways that you could make your own in this video as well. You could further save cost by making your own index plate, quite an interesting little CNC project. Or you might already have one of these, a digital block, angle block, which you could, it's got a magnet on it, and you can stick that on your chuck or on the holder in some way with a little attachment, and they're quite low cost, mass produced in China. So this can be a really low cost option. So far I've just made a few samples out of through hardened ground dowels, but that's not the way to make them for production. For a production situation, I'm going to be machining them out of O1 steel, this Bowler K460. I did buy some hardened and chromed induction hardened 3/4 inch shafting, and this could be an option for you guys that want to make your own. You can buy this 3/4 inch induction hardened shafting, and it's hard for quite a deep depth. This is not just hard chromed, but it's induction hardened and hard chromed. But I don't think that's the way for me to manufacture them in quantity. But it could be an option to get a stick of this cut off if you want to make a few for yourself, although it'll be pretty tough to machine. I think it's getting up around 60 Rockwell C. So this product is called Chrome S1 19.05. So it's induction hardened steel bar. But the problem is that it's got quite a deep depth of hardness, and you really need to grind it. You really need a surface grinder to cut through this. And also the problem is that the diameter is supposed to be 19.05, but it actually is a full thou down. So it's 749 thou, which is probably okay for most situations, but it would be better if it was just, say, a tenth of a thou below three quarters of an inch, not a full thousandth of an inch below 3/4 inch. Well, I think the sort of standard spec is 19.05, which is 3/4 of an inch, but they just mean that as a sort of standard spec. It's actually about a thou undersize, about 19.025. If I can get past the glare on the satin chrome there, but it's about a thou below spec, which is a problem for some situations. Anyway, I should be able to manufacture them for a pretty reasonable price out of O1 steel. I can machine them with centers in them, cut the flats and the point, harden and temper them, and then cylindrically grind them between centers. And surface grind the flats on them. And if I do a decent size production run, I should be able to get the price down pretty reasonable. Please don't ask me about price and supply in the comments below this video, because the videos are best kept for technical matters. Commercial matters like price and supply change over time and they need to be edited. So have a look at the website. I'll put a link in the description below. Have a look at the website for information like that, or go to contact in the website and send me an email. Alright, let's go over to Slant Pro. This could also be rapid turn. This is the last of the 3 videos, 4 including the introduction video of the Hallmark lathe tool setters. You must be getting sick of my voice if you're following them all. I'm getting sick of my voice as well. So we dial in the flat of the D section parallel with the x-axis. This is really useful. And then we set the index plate middle bubble vial, the bubble in the middle. Now that's set, it's nipped up with that little split clamp, and so the unit is now set for this lathe. Now you could have a very fine felt pen mark on the shank and on the holder, and then if you've got it on for another machine like rapid turn or a center lathe, you could have another mark for that position, and that way you could have one tool setter that would be able to be used on different machines. So anyway, we've calibrated that now and we have it set up. So next time we put it back in, we just line it back up again and it's in the correct rotational position. Why do I say rotary all the time? Well, if you've seen the other tool setter videos, I probably don't need to go into as many examples in this one, but I should include a couple. So while it's set in that horizontal position, first of all you mount all the tools, and it's very useful to have a flat anvil surface parallel with the x-axis because you can align and orientate all your tools. For example, a boring bar that's held in a round bore holder needs to be rotated to the correct orientation, and a lot of boring bars the tool is not horizontal with the X slideway but tipped on an angle, and you can just rotate it until the tip is exactly on the center height of the lathe, because this flat represents the center height of the lathe and makes it very easy to set all your tools when you're shimming them to the correct center height and turning them, if they're boring bars, to the correct rotary position. It's very useful for mounting your tools, stage 1. You can see the corners are rounded on this tool setter. That's just a legacy from the hardened dowels that I ground it out of. I think it would be better that they had sharp corners. Let me know in the comments below what you would prefer from a production version. Alright, so once we've mounted all the tools with the tool setter set horizontally or in line with the x-axis, we rotate it round either forwards or backwards to suit the particular tool orientation that we have. So we line up the bubble and the bubble vial, for example, in this boring bar that's facing forwards, and we can just come in, and there's two main methods that you can set the tool offset now. You can either, well, let's zoom in on this, see if I can get it. Whoa! Set it up so you can see light between the two, and then just step in the last little bit. I'm not very clear there in the camera, but you get the idea. And then or you can use a piece of paper of a known thickness, come in until it's just pinching on the paper. Then you would enter not 0 into the tool offsets for X, but you would enter twice the thickness of the paper because it's diameter related. So if it's 4 thou, you'd enter 8 thou diameter in, or 0.2 of a millimeter if you're in metric. And so this is pretty quick. You've got to be a little bit more careful because there isn't any retraction, and if you get it wrong and fumble, you'll chip your tool or damage something. Same for the Z. Step in until the paper pinches, or you can just see the light disappearing out of it. And then you would enter in the Z, it's just a linear amount, 4 thou plus 4 plus 0.1 of a millimeter, depending on your paper thickness and so on. So that's how you'd go through and set all your tools. If your tool is facing the other way towards the back, you just rotate. It might help if I backed off a little bit here. You just rotate the spindle, line up the bubble and the bubble vial the other way, that one. If you've seen my other videos on the tool setters, you'll know I've mentioned that sometimes you'll be at a position where there's a kink in the belt and it'll tend to ride all the time. It's usually only occasionally that happens. Then just turn it several times until you get away from that kink in the belt, and then you won't have any trouble setting it. So we just align it there, and then we can set up our tool. Perhaps I'll show another couple of examples, but have a look at the other videos and the development video linked in the description below, showing several more examples and also showing how you would set it up in PathPilot tool offsets, how you use the tool touch facility in case you're interested in that side of it. It's in the development videos part 1 and 2 linked in the description below of the prototype. Alright, well, let's set another tool. So this is a conventional turning tool in the turret. We're calling it T2. You can see that's the orientation of it there. T2. We turn the tool setter around so that the bubble vial is in the middle. And we'll come in. Try it this time by holding the camera by hand. Forgive my shaking, but I might be able to get it in a better position. And then we just step in with the X. You can see the light there. I wonder if I can zoom in on it. Alright, I'll see if I can do it by holding the camera in my hand. I'll zoom in on it. So we're on the X, we're setting the X, we just step in. If you get the light right,
you can see there pretty closely when you reach contact. See that coming in there with the light on it, and then you just enter. Well, let's do that. A very shaky example. So we put in 0 on the tool touch facility for tool 2, enter, and it shows it there in the DRO. So now we've set the tool offset in X. We do the same in Z on the end, which is dark down there. We do the same on the end, and go through all the tools and set the X and Z tool offsets like that. So all the tool offsets are set as a group that are connected together relative to each other, and all the Z's are set on the end of the ToolSetter. Now you might think, well, that's different from the end of the work. Well, the end of the work, when you put your stock in and you face the end, or you index your tool along 20 thou past the edge of the sawn off piece of stock, and you decide that's going to be Z0, then you go to your DRO, and this is your work offset, and you press that button and you set your work offset to 0 at that point, and then all of the tools that you've set in the tool table using the tool touch facility all shift together as a family to this new position. So you've been able to use the ToolSetter to very quickly set all your tool offsets and then reset them as a group to the end of the stock. Okay, well, let's take the example of using the LTS-F for setting your drill in position. So we've just indexed, we've set it with the index dial in the correct rotational position. It's a good idea to set your drills so that the flats are lined up, so that the flutes are lined up like that rather than like that. Makes it a lot easier to set your tools. And we just come in, and you can see, I'll just zoom in on this now. Forgive this shaky hand. And you can see, hopefully, you're just shutting out the light at that point. And at that point, we enter into the tool table the diameter of the tool. A plus value or a minus value depending on which side of the center line you're on. So that's an exception when you don't set X0. And then we just come in and touch off on the end. Not usually that critical for a drill, is it? And that's Z0. If I can get the cost down of these LTS-Fs low enough, some of you might want to consider buying 2 of them, because there's some real advantages. You can use the flats opposing like this for aligning, for example, in rapid turn or in slant pro, your gang tooling. You can set the rotational position and then align your bores in the other half. You can set it the other way so your flat is horizontal, and set the height either by matching the flats that way or opposing them and getting them just touching that way. And you can set your gang tooling and your turret tooling and your quick change tool post height using 2 of these. And because there's a point on the other end, you can also set using the pointers facing pointer to pointer. I know some of you will be thinking, yeah, but you just put a dial indicator in the spindle and rotate it and sweep it in and get it really accurate. And I used to think that as well, but there's a trap there. If you haven't seen my previous video on this subject, there's such a thing as dial indicator droop, and you think you're setting your bore on the carriage side in line with the spindle, but you're not. You're setting it in a different position vertically. I'll just give you an example to show you this trap.
Well, I tried to find my original clip on dial indicator droop, but I just couldn't find it. So I'll just quickly do it again here. So I've put a dial indicator on the end of a steel bar, representing if you had your dial indicator stuck on the chuck of your lathe. We'll bring the dial indicator into contact, representing your checking the bore of your gang tooling bore or quick chain tool post bore. Now we're going to rotate it. Now have a look at the dial indicator as I rotate it. See it sweeping round? It's right off the scale there. See if I can get it a bit more in contact. Alright, that's in contact there. I've done it up pretty tight. See how much it's moving? Now that's what you call dial indicator droop, gravity. In that position the dial indicator is sagging down. In that position it's sagging away from the bar. And the same thing happens when you're dialing in a tailstock or a gang tooling bore. It sags down from the top and down from the bottom. And it means that you set your bore in the wrong place. I think I should make the LTS-F with a point on the other end, a 90-degree included angle point, because that will be really useful for certain types of aligning. For example, if you've got a spotting drill or a engraving type D-bit tool that you want to set up with a central point, you can very easily line it up using the other end. And also you can use it to align with two of these setters. It's amazingly accurate if you get the light in the right place. Hold it still. You can see there within a couple of thou, or even within a thou when you've got it aligned. It's pretty good. So you can use it for setting certain types of setups, or even in the mill for setting certain types of setups, because it's a 3/4 inch or TTS type diameter. So this could have a lot of uses using the point end as well. Well, thanks for watching this video on the LTS-F. Have a look at the other two videos of a Hallmark design lathe tool set, as the LTS-M and the LTS-E as well, if you haven't seen them. Even though you might not be considering one, still some useful information on setting your tool offsets in a NC lathe. Thanks for watching. Cheers.